The last type of FRQ we're going to look at is known as graphical analysis. They will give you a graph and ask you questions about the graph. So this comes from the 2016 AP test. For this section, you need to know your justifications. Basically, your justifications are theorems. And here's a list of them. These are going to be used a lot in this section. So if you don't know them, you better learn them. Okay? So they give you a figure, and they give you function g right here. First question, does g have a relative maximum, a relative minimum, or neither? So when you see relative minimum, your brain has got to think relative minimum. The derivative changes. Whoops, let me back up here. If you can see that, I can't really highlight that for you, but the derivative changes, I guess I can, I don't know. Right there. The derivative changes from negative to positive. So in your brain, that's what you're thinking. The derivative changing from negative to positive, how do I do that? Okay, so first step for part A, I need to know the derivative of g. Okay, you have to find that. And if you look at this, the derivative, if you don't see the fundamental theorem of calculus, you need to see it. When you take the derivative of one side, wow, and I take the derivative of the other side, remember the derivative and integral from a constant to x, you just plug x in. So the first point on this, you would plug this x here in for t, and it would be f of x. That is the derivative. So I would give you 1 point for finding the derivative of g. Remember, relative max or min, you need the derivative to change signs. And if you look at 10, f is g prime, right? So this is f. What happens at 10? It's negative left and right. It doesn't change signs. So there's neither. So you would say there is neither a relative max or a relative min at x equals 10. Why? Because g prime of x, which is f of x, does not change signs at x equal 10. So that's the reason there's no sign change. It'd have to change from positive to negative to get a relative max, negative to positive to get a relative min, and since neither of those happen, that would be a neither situation. All right? So now we're going to go to part B. And what is part B asking for? Part B wants an inflection point at 4. So now we think, what justifies an inflection point? Okay, to justify an inflection point, what do I have to show? I have to show that the second derivative changes signs. So I have to find the second derivative. So for part B, the first step is to find the second derivative of g. Well, from here, you take the derivative of both sides, that's just going to be f prime of x. So I would have given you a point for finding that. That's your first step. Now, what are we going to do? This is 2016. So how do we see if the second derivative changes signs? Well, that would mean f prime changes signs. This is f. How do I know if the derivative is positive or negative? So this has to do with knowing another justification. Okay, it's all about justifications. So what tells me if a derivative is positive or negative? If the original function is increasing, then the derivative would be positive, and if the let's go back and look why. Let's go back here. So look at these. You need to see the relationship between increasing and decreasing and the derivative positive and negative. You just have to know that. It's got to be ingrained in your brain. So when you see this and you think, okay, in order to show inflection point, I need to show that the second derivative changes signs. We just saw that, so I need to show that. But how do I show if the second derivative changes signs? Well, let's find the second derivative, which comes out to be the derivative of f. So I have to show the derivative of f changes signs. What tells me if the derivative is positive or negative? That's if f is increasing or decreasing, right? So here is what I would have. Here's the logic. And this one, takes some time to develop, but with time, we can figure these out. So first step, is g positive or negative? Left and right of 4. Well, here's 4. Notice from 2 to 4, f is increasing, right? If f is increasing from 2 to 4, that means f prime is positive, making g double prime positive, right? So I will state f is increasing on the interval from 2 to 4, right? Therefore, f prime is positive on that interval. Okay? And then let's look at what's going on from 4 to 8. F is decreasing. So I'm going to do the same logic here. F is decreasing on the interval from 4 to 8, right? Therefore, its derivative would be negative on 4 to 8. So what have I done so far? I've shown that the derivative is positive to the left of 4. It's negative to the right of 4. So I've shown that at 4, it changes signs. And that's what I need for an inflection point. So my conclusion, you have to be very explicit. G has an inflection point. G has an inflection point. At x equals 4. Why? I need a justification. What's the justification for an inflection point? Again, if the second derivative changes signs. That's what I need to say. Does the second derivative change signs? Yes. So here's the justification. Because g double prime of x, which is f prime of x, changes from, and let's see, it went from positive to negative at 4. And you don't have to say from positive to negative, you can just say changes signs. Let's do that. Oh, I already have from. Changes from positive to negative at x equal 4. So I'm done. I've done it. I've used all my justifications. So the final, to show inflection point, you need the second derivative changes signs. Well, I have it changing signs. How did I get that? Well, I know the second derivative of g is equal to the first derivative of f. Well, the first derivative of f, we had f increasing from 2 to 4. Therefore, f prime is positive. We had f decreasing from 4 to 8. Therefore, f prime is negative. But f prime is g double prime. So we have g double prime changing signs at 4. So we're done. We've done it. G has an inflection point at 4. The justification, you have to have these, because g double prime, which is f prime, changes from positive to negative at x equals 4. And the work to show that appeared up here. So that's part B. Let's move on to part C, and I'm going to erase this stuff because this is all going to get in the way. Okay, I'm going to leave these because we might need those in the next part. Whoops, I'm doing part C. So find the absolute minimum value and the absolute maximum value of G on the interval from -4 to 12. Okay, so first thing, where do max and mins occur? And we should know critical points and endpoints. So we need the derivative of G and set that equal to 0. So G prime of x, which is f of x, equals 0 at. Well, where does it equal 0? And our interval is -4 to 12, so we're looking at the whole thing. It's going to occur at -2, 2, 6, and 10. That's a lot of points. So now we found all the critical points. Now, technically, we wouldn't have to test every single one of these points because here, the derivative, because G prime is f, so G prime changes from negative to positive here. That's a real min, right? So that's a possible point. Oh, they want absolute max and min. Okay, just to point this out, 2, there's neither a relative max or min, so it's not going to be an absolute max or min. And 10 also, because the derivative doesn't change signs there. But let's go ahead and test all points. So we need to find the value of G at endpoints, which is -4, all the critical points, and the endpoint, which would be 12. Okay, I would need to find all of these, and whatever one's the biggest will be the maximum, and whichever one's the smallest will be the minimum. So that's what's going on here. So how do I do this? Okay, we have to just plug these numbers into this G function. So let me write this bigger. So we're going to integrate some of them are easy. 2, if you put a 2 there, the net area from 2 to 2 is 0. I'm done. 0. That's easy. What if you put a -2 here? So you're going from 2 to -2. The area, this is 4, and that's 4. The area of a triangle with a base of 4 and a height of 4 is going to be 1/2 4 times 4, 1/2 base times height. But you're going backwards, so it's going to be negative. So that's going to be -8. Then, what's it going to be if we go all the way to -2? So we're going to plug in -2. So we're integrating from 2 to -2. We're going from here, to -4, sorry, -4. Put the same number in twice, kind of lame-o. So we're going from here back to here. Now, as we integrate backwards, you're going to see that area and that area cancel out, right? So the integral is going to be this, which is 1/2. The height is 4 and the base is 2. 1/2 base times height. But again, it's above, which is normally positive, but since I'm going backwards, it's going to be negative. So that's going to be -4. And then we'll go to 6. So the integral from here to 6, we're going forwards. So that's going to be 1/2 base times height, which is 1/2. The base is 2 and the height is 4. So that's going to be 4. We're just doing net area, and we're finding the area of that shape. 10. Next, we're going to go to 10. If we go all the way out to 10, we're integrating from here to here. Notice the area here and the area here cancel each other out, so that net area is 0. And the last one's going to be 12. So if we're going from here to 12, that area is going to cancel out that area. This area is going to be negative, and it's going to be 2 times 4, 1/2 base times height, negative 1/2 base times height, which is going to be negative 2. All right, so those are all the values. The max is going to be the biggest one, and the min is going to be the smallest one. So that's what I need to do, right? So let me take a look. What year was this again? 2016. Just want to make sure I'm getting the right one there. So which one is the smallest number? Clearly -8, right? Clearly -8 right here. So find the absolute minimum value. So g of x has a minimum of -8 and a maximum, which one's the biggest, of 4. So -8 is the, or -8 is the minimum, and the maximum, I think I messed up here real quick. Let me take a look what's going on. If I go to 6, so 2 to 6, the base is 4 and the height's 4. It's 4 by 4. How did I miss that? And so that's going to be 8. So the maximum value is going to be 8. All right, so max and mins, the principle, they occur at critical points or endpoints. So I found my critical points and endpoints. Then I found the value of the function at all points. And it turns out the maximum is 8 and the minimum's -8 by looking at all the values of g. All right, we have one more step, part D. And let me erase A and B. Give me some space over here to do the last part. D. We want to know when g is negative. Okay? This one, there's really not a lot of work to do. It's more of a thought process. So we're starting at 2. And as we integrate backwards, it's going to be negative, right? Because anything above is normally positive, but when you go backwards, it's negative. So from here to here, you have a pretty negative, the area of that's negative, right? But as we continue, the area below is not enough to counteract the area above. So it's going to be negative all the way from -4 to 2. Okay? Now, as we integrate to the right, you're going to add this area. It gets bigger and bigger and bigger. So you're going to get the area of this as a positive. Now you're going to start subtracting all of that. And when we get to 10, that area and that area cancel each other out. But as we go from 10 to 12, this is below the x-axis, so you start subtracting. So it's going to be negative on the interval from 10 to 12. So those are the regions. G of x will be negative or 0 on the interval from -4 to 2 and from 10 to 12. All right, now does it say or equal to 0? Yeah, since it has an equal, it's going to equal 0, so I need brackets at the endpoints, because at the endpoints it's going to be exactly 0. So I should have that. And that is the end of the 2016. Let's move on. It's actually the 2017. This label is wrong. It's 2017 FRQ, number 3. So a couple things going on. They tell us f is differentiable, so the derivative exists everywhere of f. This is the derivative f prime. They tell us f of -2 is 7, so I kind of just highlighted that there. And they tell us it's a semicircle and 3 lines. So they want f of -6. This is the classic fundamental theorem of calculus question. They give you the value of f at one point, they want it at another, and they get f prime. So if you know the starting value, what was f at -2? And if you can figure out how much f changed from -2 to 6, you can figure out how much it is at -6. So to get that, we integrate from -2 to -6 f prime of x dx. This gets us the change in f. So I'm integrating from here backwards. Remember, when you integrate backwards, it's opposite. So anything above is negative, anything below is positive. So this is going to be 7. And since it's above, we're actually going to subtract it because we're going backwards. And the area of a triangle is 1/2 base times height. The base looks like 4 spaces, and the height is 2. So it's 7. You could stop there. We're done. But 7 minus 4 equals 3. But you can stop here. You should stop there. Okay? So that's f of -6. Let me do the other one, f at 5. It's the same thing. You need the starting value plus the amount of change from -2 to 5, and you find that by integrating the derivative. That gives you the change in f. Again, we start with 7, but now we're going from here to here. So you're going to subtract that because it's below and add that because it's above. All right? So that's going to be minus, because the semicircle is below. The area of a semicircle is pi r squared, but it's half, so we divide by 2. Then we have to add that triangle above, which is half base times height. The base is 3, and the height is 2. So we get 7 minus 2 pi plus 3. Now you should stop here. But just to go all the way, it's going to be 10 minus 2 pi, and that's going to be the answer for part A. So all that was part A. Part B, on what intervals is f increasing? Okay, this one is actually a pretty easy question. The justification for f increasing, make sure you know that. Let me go to this. F increasing, right there. F is increasing if f prime's positive. So this is pretty straightforward. Where is f prime positive? From -6 to 2 and from 2 to 5. So I would say f is increasing on, so I'd go -6 to -2 and 2 to 5. And I need a reason. And the reason is because f prime is positive on those intervals. Again, it all goes back to the justifications. You have to know those. To justify increasing, you have to prove that the derivative is positive. Well, clearly it's positive in this region and that region. So from -6 to -2 and from 2 to 5. -6 to -2 and 2 to 5. And the justification, because the derivative is positive on those intervals. Okay? Let's go to part C. Find the absolute minimum value of f. So absolute minimums occur at critical points or endpoints. So you need to find where the derivative is 0, and that occurs at -2 and 2. And how do you know where the minimum value is? You need to find f at the endpoints, which is -6, at the critical points, which are -2 and 2, and the other endpoint, which is 5. So if we can find the value of the function at those points, we can tell which one is the maximum. So f at -6, we already found that. We found that in part A, and that was 3. And we found f at 5 in part A, and that was 10 minus 2 pi. So that's pretty nice. And then f at -2. So f at -2 is a given. They told us that. F at -2 is 7, so that's easy. So we have one more left we have to find. That's going to be f at 2. So let's find f at 2. F at 2 is going to be the starting value, which we know f at -2, plus the integral of f prime of x dx from -2 to 2. Well, we start again at 7 that we are given. What's the integral from -2 to 2? The integral from here to here, it's going to be the net area. So we have to subtract that area. So we're going to subtract, not add that, because the integral is below the x-axis. So it's minus pi r squared, and it's a half a circle over 2. So that's going to be 7 minus 2 pi. And we are trying to find the absolute minimum. So pi is roughly 3, right? So that's going to be 6. 7 minus 6 is roughly 1. So that's going to be the smallest value. So the conclusion, the minimum value of f on the interval from -6 to 5 is 7 minus 2 pi. And that's it for part C, absolute minimum. All right, part D. All right, let me erase C and B, and we will do, hopefully it doesn't erase the box. Okay, so part D. Find f double prime at -5 and f double prime at 3. Okay, this one's going to be kind of interesting. So we have the graph of f prime. So f double prime at -5. -5 is 1, 2, 3, 4, 5. So we should know the derivative is the slope of the tangent line. This is going to be the slope of that line, right? So how do we find it? We're going to take the slope formula. So we're going to do f at -6 minus f at -2 over -6 minus -2. To find the slope, you subtract the y's, that's the rise. You subtract the x's, that's the run. So f at -6 will be 2 minus 0 over -6 plus 2, which is 2 over -4, -1/2. That is the slope at -5. Okay, what's going on at 3? Now, at 3, it's a sharp point, right? And therefore the derivative doesn't exist, but you need to give a reason why. You can't just say it's a sharp point. It all comes back to the definition of the derivative. So we're going to say f double prime at 3 does not exist, but I need to give a reason. Because, so you got to remember that derivatives are limits. So if the limit from the left doesn't equal the limit from the right, then it's not going to work. So we can write it this way. The limit as x approaches 3 from the left of f double prime of 3 equals, And we can see that slope is going to be what? A rise of 2 and a run of 1 equals 2. And the limit as x approaches 3 from the right of f double prime of 3. So the derivative from the right, that's going to be a slope of what? Negative 1? So, therefore, since the limit as x approaches 3 from the left of the second derivative does not equal the limit as x approaches 3 from the right of the second derivative, f double prime at 3 does not exist. Now, technically, I wouldn't need all this because it's redundant. So I found the slope from the left is 2, the slope from the right is 1. Therefore, from the left and right, they're not equal. Therefore, the derivative does not exist. Okay, now, there's other ways to write these that are more technical using the actual definition of the derivative, using the f of b minus f of a over b minus a definition, or the other one, but we could just leave it at that. We should be fine. All right, and that's that question. We will move on to the last one, 2019. So this is 2019. This is the graphical analysis FRQ. So point out a few things. We're told we have 2 lines and a quarter circle. We're told the center of the circle is at 5, 3. We're told the circle goes to the point 3, 3 minus radical 5. And in part A, we're told the integral from negative 6 to 5 is 7. So they want the integral from negative 6 to 2. So what are we going to do? So you can see that is part of this interval. We start at negative 6. We want to end at negative 2. So this is kind of weird, but we want to end at negative 2. Okay? And so here's the weird thing. As long as these are the same, we start at 6, end at negative 2, we are legit. It's going to work, and we have no problems with it. Now let me put these in. Let's fix this here. So what number should we choose? Well, it's going to be 5 because we have 5. So 5 is the logical choice that we should pick here and here. Okay, and then for the first part, negative 6 to 5, we know it's 7. They tell us that. So if we can figure out 5 to negative 2, that will be the answer to this. Okay, now we're going from here, we're going backwards. And again, when you go backwards, the net area is opposite. Things above are negative and things below are positive. So we need to get the area of this, and we're going to make that negative. But what is this? This is a triangle. We can find the area of that. But how are we going to find the area of this? Well, the way we're going to do it, we're going to take the whole area of the square and subtract the area of this quarter circle, and that gives us this little piece here. And all that's going to be negative because it's above the x-axis and we're going backwards. So first, to get the area of this, I'm going to take a square, which is, how wide is it? It's 1, 2, 3 by 1, 2, 3. So that's going to be 9. And I'm going to subtract the area of a quarter circle. So the radius is 1, 2, 3. So it's pi r squared. Pi r squared divided by 4, because it's 1/4 of a circle. So that's the area of this piece. And I want to subtract the area of this triangle here, because that's above and we're going backwards, so it comes out negative. So that's going to be minus 1/2. It's a triangle. The base times height. The height will be 3, and the base is 1.5. Okay, if you look at the slope, it's a rise of 1, 2, 3, 4, and a run of 2. So the slope is 2. So it's up 2 over 1, up 2 over 1. So that's what we're going to get. So this will be the area of the triangle. Okay? And again, since this has a slope of 2, it's going to go up 1 over 1/2. That's why we know it's 1.5 wide. 1 here and then 1/2. Then, this is below right here. We're going to add that since it's below. It's a triangle again. So we're going to add 1/2. The base is 1.5 again, so 3/2, and the height is 1. So from here to here, it's 1.5, and this distance is 1. And then we have to subtract one more triangle. And the last triangle, it's 1/2, 1 by 1. 1/2, 1 by 1. So that is the answer. You do not have to simplify that. I'll go ahead and simplify that to see if my answer matches what it's supposed to be. Kind of crazy, huh, for part A? And I'll erase it when I'm all done. Now, you shouldn't simplify this. 9 minus, and that's going to be 9, and that's going to be plus 9 pi over 4 minus 9/4 plus 3/4 minus 1/2. Crazy. I can combine these. No, I can't. I can combine these. So negative 9 plus 3 is negative 5/4. So I'm going to get what? Negative 2 here. 9 pi over 4. Negative 6/4 minus 1/2. All right, so simplifying this further, we get negative 2 plus 9 pi over 4. This is minus 1.5 minus 1/2. So that's minus 2 is minus 4. So 9 pi over 4 minus 4 would be the simplified answer. But like I said, you should stop right here. There's no reason to go any further than that. Okay? It's a waste of time and too easy to make a dumb mistake on this one. So that's part A. The concept there, the big concept was an integral could be broken up into two separate integrals as long as your start is the same start, your end is the same end, and these can be any number as long as they're the same as each other. Okay, so that was the big picture for part A. Let's go to part B. Okay, so part B, again, it's a property of integrals. You can break an integral into two separate parts. It's 2f prime of x dx plus, and then we're going to do 4 dx. And then the next concept, you can pull a constant out in front. So we'll take the 2 out in front. We have f prime of x dx plus the integral of 3 to 5 of 4 dx. Next, we need to take antiderivatives. What's the antiderivative f prime? It's just going to be f of x from 3 to 5 plus, and the antiderivative of 4 would be 4x from 3 to 5. And we're going to get 2f of 5 minus 2f at 3 plus 4 times 5 minus 4 times 3. And that's what we have. And from the table, we could probably get f of 5. F of 5 is 0 from the table. So that's 2 times 0 minus f of 3. They tell us is 3 minus radical 5. They gave that to us earlier. 2 times 3 minus radical 5 plus, and that's going to be 20 minus 12, which is 8. So we end up with 8. And again, at this point, you should stop. Don't go any further than that. That's 0. I distribute the minus sign here. I'm going to get minus 6 plus 2 radical 5. So that's going to give me 2 plus 2 radical 5 as my answer. And that's part B. That's just using the properties of integrals. So basically the first two are properties of integrals, making sure you know all the different things you can do to integrals. All right, part C, absolute maximum of G. So they define G as this, and they want the absolute maximum of G from -2 to 5. And so the question, where do maximums occur? At critical points and endpoints. So to find the critical points, I need the derivative of G, and again, fundamental theorem, so common. I take the derivative with respect to x on both sides. If you take the derivative of an integral and the bottom's a constant and that top variable matches that, all you do is plug that into the function. So this is simply f of x. That happens all the time. Fundamental theorem, you better know that. And we want to set this equal to 0. When does f of x equal 0? And it's going to be at -1 and 1/2. -1 and 1/2 at x equal -1 and 1/2. So now I have found my critical points. Now I need to find the value at G at the endpoints. So left endpoint's -2. The critical point is -1 and 1/2. And the right endpoint is going to be 5. So if I can find the value of G at those 4 points, the highest one has to be the maximum, and the smallest one has to be the minimum. So this one's pretty easy, -2. What's the integral from -2 to -2? Well, the net area clearly is going to be 0. There's no area underneath that. And then G at 5. Well, let's go G -1. We'll do one at a time. So I want to integrate from -2 to -1. Okay? So I'm starting here and going right. So the net area is going to be 1/2. It's the area of a triangle. It's 1/2 base times height, which is just 1/2. Okay? Now the next one's 1/2, which is here. So I want to integrate from here to here, which is that triangle minus that triangle. Well, the top triangle is 1/2, 1 by 1, minus, because the second triangle is below the x-axis, so the net area will subtract that. The base from here to here is 1.5, so I'm going to put 3 halves, and the height is going to be 1. So that's going to be 1 minus 3/4. That's going to be -1/4. And the last one, 5. So I want to take this area and that area, add them, and subtract that area. Well, I did this one earlier. It's all erased, so I'm going to have to start all over with that. Kind of a bummer. But let's just go ahead and do this. I'll start my way across. So that's going to be +1/2. So it's 1/2 base times height minus 1/2 base is 3 halves by 1. We did that earlier. Plus, and now we're going to do this triangle. And again, the base is 1.5 and the height's 3. So it's 1/2, the base is 1.5 and the height's 3. Now I want to subtract or add this. How am I going to do that? Remember, I take the area of the square, which is 3 by 3, and I'm going to subtract the area of a quarter circle. So I take the whole square, which is 9, and subtract the quarter circle, which is pi r squared over 4. So minus pi r squared over 4. That is the answer for g of 5. Now, if I were to simplify this, again, do not simplify. Do not simplify. Do not simplify. So that's going to be 2.5, 11.5, 12. 12 minus 3/4 is 10 1/4. I think I made a mistake somewhere. Let's double check this. So that's 2 1/4. Okay, 2 1/4. 11 1/4. 11 3/4 minus 3/4 is 11. 11. That's why you shouldn't simplify, because you'll just do what I did. So this is the answer to part C. Or was that B? I'm losing track. No, part's O. No, I didn't answer the question yet. Golly gee, that's not good, Yoshida. What did the question ask for? Don't even know. The absolute maximum. So we have 0, 1/2's bigger, that's smaller. And then this, what is that? So this is about 3. That's about 27. 27 divided by 4? I don't know, 6 or 7, say it's 7. 11 minus 7, that's going to be 5. So that's going to be bigger than anything else. So we would say G has a maximum of 11 minus 9 pi over 4 on the interval from what? -2 to 5. Bammo. That's part C. All right, we have one more to go, part D. Let me erase all of this. And we are almost finished. So part D, we have a limit. And I already know, I don't know why I can tell you this, but I'm just sensing L'Hopital's. That's what I'm sensing. So let me take the limit of the top and the limit of the bottom separately. That's what you need to do in L'Hopital's. We're approaching 1. So we can talk about this. F prime at 1. It's the slope here, and the slope is 2. So that's going to be 6. 2 times 3 is 6. 10 minus 6, that's going to be 4. Maybe it's not going to be L'Hopital's. I don't know why I thought that. Is it L'Hopital's? Let me double. No, I don't think it is. Never mind. So this limit is going to be 10 to the first minus 3 f prime at 1 over f at 1 minus arctan of 1. That's going to be 10 minus, and the derivative at 1 is the slope at 1, which is 2. So 10 minus 3 times 2 all over f of 1. F of 1 is 1. And what angle has a tangent of 1? That's going to be pi over 4. 10 minus 6 is going to be 4 over 1 minus pi over 4. That's my answer. I am so blown away that's not a L'Hopital's, but that's the end of this FRQ.